Okay, so we have our four matrices that we're going to use. And again, we're going to do scalar multiplication, which is just where we take a number and multiply it by a matrix. There are no rules for that. You can just take that number and you basically multiply it by every term in that matrix. But one thing you do need to know is that number that we are multiplying by. So for example, in question number 1, that 3 is called a scalar. That will be a question on your quiz on Friday. Okay. The number in front that you are multiplying by is called a scalar. So you might want to jot that down because it will be a question on our quiz. And again, all this means is we're going to take that number and we're going to multiply it by every term in our matrix A. Okay, the letter tells me which matrix to use. The number tells me what I'm multiplying by. So if I take every term in matrix A, every element, and multiply it by 3, so 4 by 3 gives me 12. 2 by 3 gives me 6. 6 by 3 is 18. Negative 2 times 3 is negative 6. 0 times 3 is 0. And 1 times 3 is 3. And that is all you have to do for that. Make sense? Go ahead and try number 2 then. Well, those are like 7, 8, 9, and 10. 1, 2, 3, and 4. Oh well, same difference. Doesn't really matter. So if I multiply C by negative 2, what's my first row going to look like? And my second row? Okay. Yep. And then the next two, it's very similar, but it's also combining what we did yesterday as well. I'm just going to relabel those. I'm not sure why those are that number. So for number 3, it's 2A plus 3B. So what we will do is multiply A by 2, multiply B by 3, and then add them together if you can. Remember yesterday we talked about being able to add them. They have to be the same size. Okay? So we can multiply them by their scalar and then add them together. So if you will go ahead and try number 3. Yeah, and then like to add them. So for example, yesterday we were just adding A plus B. They have to be exactly the same size. Number of rows, okay, is horizontal, and then the columns. You notice they would be the same. So to add them, we would just take like 4 plus the 3. So what we need to be doing is multiplying A by 2, multiplying B by 3, and then adding if we can. If we can't, then you would just leave the new matrices that you have multiplied as one plus another. If you can't actually add them together, you can do the multiply. But if they can't add together, just leave them like that. So I'm going to start by multiplying A by 2. And then I'm going to multiply B by 3. And then can I add them together from there? Are they the same size? Yeah. So then we just do like we did yesterday, adding each term together. So starting 8 plus 9 is 17. 4 plus 0, 12 plus negative 6 negative 4 plus 3, 0 plus 15, and 2 plus negative 21 is negative 19. So that would be the answer for that one. If you haven't already, go ahead and do 4. Not very many of these today because they are. Over here. I need to empty it. Number 4. So 4 times C, 5 times D, and then you're going to subtract. All right, so let's see. 4 times C is going to give me 16, 0, 32, negative 4. 5 times D is going to be 25, 0, 10, and negative 30. And then are we actually able to subtract them? Yeah, they're the same size. So let's see. 16 minus 25. What is that? Negative 9. 0 minus 0. 32 minus 10. Negative 4 minus a negative 30 turns into negative 4 plus 30, which is going to give me 26. Does that make a little bit of sense? Okay. I have 2 more. Same 4 matrices. I have them written again. You don't have to write them again. I just did it so that we could see them. Okay, last 2. Very easy stuff today. So this time we have our scalar, that 3, on the outside of the parentheses, and I have 2 matrices inside parentheses added together. So you can do this one of 2 ways. The first way we could do it is if C and D can be added together, we could add them first and then multiply by 3. Or usually when we have things on the parentheses, we also do what to it? Distribute it. So you could multiply 3 times C, 3 times D, and then add together. So that's up to you. You want to add first and then multiply once? That's probably the quickest way to do it. That is if C and D are actually able to be added together. If they're not able to be added together, then all you can do is multiply each matrix by that number on the outside of the parenthesis. And you'll be able to add. It just depends on if you want to multiply twice and then add, or if you want to add and then just multiply once. Am I actually able to add C and D together? Yeah. I personally would probably add first and then multiply. That way I don't have to multiply more than once. So I'm going to keep the 3, and I'm just going to put it on the outside of the matrix. And then I'm going to add C and D together. 4 and 5 is 9, 0, 0, 0, 10, and negative 7. And then all I have to do is multiply each one of those terms by 3. And either way, that should be my result, whether you multiplied each one by 3 first and then added, or add and then multiply. That is up to you on how you want to do that. What's a bit different about number 6? You can't add those together. So all we can do is multiply each matrix by 4. So I'm just going to take and multiply our matrix A by 4. And then I'm going to put a plus sign in between. And then I'm going to multiply matrix C by 4. And then I won't be able to do anything else because they are not the same size. Therefore, I cannot add them together, and I would just leave the answer like that. Does that make a little bit of sense? Again, that number that we're multiplying by is called a scalar. That will be a question on the quiz. And I can tell you every year people miss it because they forget to write that down. I will remind you when we review tomorrow, but you might want to put that in your notes. The number that we're multiplying by is called a scalar. Anybody have any questions?